Back in the mid-80s, when IRAS first brought us its infrared imagery, some objects just leapt out, appearing unlike anything else. Since the advent of easy-to-access sky maps from the likes of Google and WikiSky, IRAS imagery could be brought forward to allow anyone to have a look at the types of sights it saw. Indeed, for a time it was even possible to type Nibiru into the WikiSky search box and be brought to this object. That must be proof that it's Nibiru, right? Wrong. Some of those working on the IRAS data had the same reaction you might have had upon seeing this imagery. Some said it could have been a 10th planet, due to its sitting near the ecliptic, the plane of the planets. But all of them did what they do best. They researched it further. This object isn't Nibiru, but a carbon star about 650 light-years away, known as CW Leonis. What's so special about this star compared to other stars? Why does it have this striking appearance in the infrared? CW Leonis, found in 1967, is an ideal object to study in order to understand things like mass loss in the late stages of stellar evolution, essentially where all the stuff from a star goes during the star's death. It is so ideal for study, in fact, that it's the most studied carbon star that has been discovered, and quite a bit is known about it. Being a carbon star simply means that there is more carbon than oxygen in its atmosphere, and the processes that take place here lead the star to be caked in soot, if you will, surrounded by a thick shell of dust comprised of all manner of molecules. With the rate at which the star is losing this mass, and that mass going on to form an envelope around the star, it turns out that it's hard to see the star itself in visible wavelengths. In fact, it was only discovered because it was visible in the red band of the Paloma Observatory Sky Survey and not the blue, as you can see from these images. And later surveys with multiple wavelengths, like the Sloan Digital Sky Survey, have shown the emissions from CW Leonis are towards the red and mostly the infrared end of the spectrum. But how can we be sure that this object is CW Leonis and not Nibiru? To begin with, let's make sure we have the correct coordinates. We can search Simbad, an astronomical database of some 4.8 million objects, and it returns a star name, CW Leonis. So far so good, these coordinates are known to be those of the star we're looking at. But do they definitely point to the strange-looking feature in IRAS? Well, let's have a look at the many catalogues available to search through at the Infrared Science Archive. We can choose to search the IRAS catalogues directly, so we can see what IRAS saw and in the wavelengths it saw it. Sure enough, if we put in our coordinates for CW Leonis, we see the same feature that we see in WikiSky. So with what we know and have studied about the star since the late 60s, and with coordinates and data that support the view that we're looking at the same object, we have an abundance of evidence for this object to be CW Leonis. What evidence do we have for it being Nibiru instead? Well, when it was listed as a search term, we were brought here. Unfortunately, we're going to need a bit more evidence than that. SkyMap is built upon the ideals of a wiki, hence its second name of WikiSky, and it is something that anybody can add to and enhance for the benefit of the users. It is therefore entirely possible that Nibiru's inclusion as a search result was a little joke, a nod to the 80s when this was first thought to be something other than a star. It could even have been someone hunting for anomalies and naming them Nibiru without researching them properly. However, you may not take any of that as an acceptable answer from me. You may think that it's been covered up as part of the conspiracy, for example. You may not even accept that this feature is CW Leonis in the first place. If so, here is what you need to do. There are hundreds and hundreds of catalogues that can be searched through, from multiple sky surveys, from different satellites across many wavelengths, studying various kinds of objects. And we can do this extensive research for any position in the sky you wish to name. Get the coordinates that you think show Nibiru. Test them against these massive databases to see what is known to exist at that position. Alternatively, if you think we are already looking at Nibiru here and not CW Leonis, then expand your research and tell us why it cannot be CW Leonis. After all, if your evidence for it being Nibiru is stronger than the evidence that says it is CW Leonis, then you and your claims are in a very good position. Ask yourselves this, for example. CW Leonis hasn't moved since the 50s, when the first sky survey imaged it, through to the 60s, when it was discovered within that data, the 80s, when the IRAS took a look, the 90s, when the SDSS imaged it. But isn't Nibiru supposed to be a moving object? Searching through endless databases full of astronomical jargon sure isn't as instant and pretty as searching on WikiSky and Google, but it is a necessity in order for you to make a solid claim. If you don't use them to prove Nibiru, then others will use them to counter your arguments. As I have said often enough, if you want Nibiru to be taken seriously, you must put in the research. We ask for nothing more than testable evidence, and yet we're provided with nothing but nonsense.